Hello, everyone. So I hope you've been having an amazing day today. I've had a lot of fun. Hope you have as well. And of course, today, very, very special day for Ethereum. Very, very special day for Starknet here, first StarkCity in London. And to celebrate this and close this amazing day we've had all of us together, we have a very, very special guest that needs no introduction. So Vitalik, please welcome.
Right. Hi, can everyone hear us? Can you hear us okay? Yeah. Sounds okay? Very good, thank you. Vitalik, thank you for being with us today, especially on such a special day, the activation of the Denkun upgrade on Ethereum. We talked about it at length earlier. So first of all, for those who were earlier on the panel, I did confirm Denkun is, the name of Denkun comes from Deneb, the star, and Cancun, the city from an Ethereum conference. We were wondering earlier, now we get the answer. Thank you. So thank you for being here on that day. We talked at length about the technical aspect of 4844 so far, and I'm sure we're going to get a bit more into it later on. I guess my first question is, what goes on behind the scene when there is such a massive upgrade on Ethereum? Are those stressful for you, for the teams involved? How is this happening?
Yeah, no, the parties are, definitely continuing to be stressful each time. You just first, like everyone gets together either in person in front of the big TV or remotely in front of 1,000 big TVs and like many more big and small laptops, and then. The fork slot happens, and you think the fork slot is when you celebrate, but in reality, the fork slot is when it starts, right? And then you got to wait your 3 epochs and make sure that a block after the fork actually gets finalized, and if there's some new feature that a block that actually uses that new feature gets finalized, and that you still have consensus, and it's definitely less stressful than before, I think, just because everyone has done it so many times that it's just become a ritual, right? Like everyone knows, okay, fork is happening. These are the explorers you turn on, and these are the things you put in your tabs on the big TV, and this is what you watch for. This time, actually, things went very well, right? We got 95% attester participation after the fork, which is everything pretty high, everything quite smooth. So everything definitely went well. I think, ironically, I think the one thing that did not go well is that Blobscan, the Explorer, crashed. Though now that's back up too. Yeah, I mean this one is interesting, right? Because it's not just tweaking things, it's introducing a fundamentally new feature, right? And it's fundamentally introducing a new component in a sense, right? And the only time we did that before was, of course, the merge itself, right? No, seems like it's gone well, and it seems like people are enjoying the blob so far, so all good.
Nice. So the people who are involved in those upgrades, are those, is this mostly consensus client teams? Is it execution clients team? Is there a core of people who communicate around this? And then I imagine there's another circle of people. I mean, we've been following, we're an L2, so we've been following this closely. Do those people communicate in any way? I don't know. what is the nervous system of the Ethereum body?
Yeah, I mean, there's lots of communication at every step, right? So people from consensus and execution client teams are, generally there at all of these in person when it actually happens. But then, there's the entire pipeline of things that happens before you actually get there, right? And there's the all-core devs calls. There's often breakout calls on all kinds of specific topics. There is in-person meetings, right? So there's retreats that get organized that contain all of the execution client devs and consensus client devs and a bunch of other people, and 100 people come together for a week or so. So one of those happened in Athens about 2 years ago for the merge. Then one of those happened in the wintry mountains of rural Austria in January about a year ago. So more of those are going to happen in the future. So the in-person stuff it definitely really helps. So yeah, many kinds of communication of all kinds go into making each one of these a success.
Very nice, thank you. So maybe now on 4844 specifically, one question I wanted to ask you is, blobs essentially introduce a new feature or a new component in the block in Ethereum, where you have data with a shelf life that is published, and the network attests that it has been public for a while, but then nodes don't have a requirement to keep it. Is that a big paradigm shift? Is it something new in blockchain world to have data that is discarded and disappears? Are blockchains forever, or is it something that is?
Yeah, I mean, I think this is like a really important misconception to clear up, right? Because like a lot of people are getting this impression that like blobs are sort of less part of the chain than everything else. And like it is true that blobs are like the first instance of this new paradigm where like default nodes don't store everything forever. But you know, in reality, there is this longer-term roadmap with EIP 4444, where like even just like regular block bodies and receipts are also going to be a thing that like by default nodes don't store forever, right? And like you always have a choice to run an archive node that does store, I mean, like literally everything forever, right? But the way that we're thinking about this is that like really like for like verifying that things are there and things are correct in real time, when you know you want every node to be involved, right? But for storing history, like the thing that like the kind of architecture that makes more sense, right, is a peer-to-peer architecture where you use things like distributed hash tables. There are things like the portal network, other things where you still have huge amounts of redundancy and enough redundancy to ensure that nothing is ever actually going to get deleted, but without like literally requiring each and every node to store everything, right? And like what that kind of architecture does is it still preserves the guarantee that the blockchain stays available forever, but it allows it to scale much more, and it allows it to like persist for a much longer period of time, right? So. Yeah, the long-term goal is to move to this kind of approach also for the core Ethereum L1, right? And so you still have proofs of history, you still have the ability to download things from these peer-to-peer networks that are currently in the process of being built, right? But like that's the end game that's being moved towards, right? So I think. The long-term roadmap is for like blobs and execution to be treated similarly in that way, right? I mean, possibly with some differences on the constants, right? Like it could be that blobs get stored for 18 days, but then execution data gets stored for like 72 days or something. Like these are things that are going to get figured out over time, right? But the roadmap definitely is toward accommodating more different types of nodes, and statelessness is also another example of this, right? Where default nodes are going to become lighter and lighter so that they continue to become more and more affordable for people to actually run, which is something that everyone says we need to improve on, and we are improving on. But at the same time, we have these, like we continue to provide these strong guarantees that the data can be downloaded, but like there are smarter ways to provide that guarantee than having literally every single node kind of store everything forever by default.
So if the way we store data changes and the role of node changes, do you think that managing data is something that will be entirely managed by companies, service providers, and infrastructure projects? Or do you think this also changes the way users need to think about how they interact with the chain and they back up their assets? I mean, right now, most people would assume that if they have a seed, they have access to their wallet, and their assets are here forever.
Yes,
here, maybe
that continues to be true.
I'm sorry?
That continues to be true, right?
But if the data is not there, do you think they should expect this to be? I mean,
okay,
if they don't have the data,
right? So the state, right, is So if you have coins, your coins are part of the state, right? And the state, like, I mean, obviously, if you could, especially after Virtual trees, like you could run a client that only stores the state and that still keeps the state updated, right? I mean, you could even do that today, potentially, like if you write the code yourself, right? But realistically, like the state is a necessary piece of information to have to even construct a block, right? So there's just like very strong practical guarantees that the state is going to be extremely easy to find, and there's incentives for like huge numbers of actors to have access to it, right?
Okay, so you're right for Ethereum. Maybe
Yes.
taking the point of view of a user of a rollup, like
Okay,
for example.
yes, that's,
right? You're using a smaller rollup.
Yes.
You know, do you have
Yes,
you
that's,
will always be able to get out if you have the data. If
Right.
you have the data, how do you deal with that?
Yes. So I think I think of it as like there are probably different levels of guarantees, right? So the first level is the rollup itself is going to have its own infrastructure, and rollups themselves are going to have rollup nodes, and rollups themselves already do have rollup nodes, right? And if you care about having the guarantee personally, you can run one, and if you do that, then you're like basically going to be an archive node of just the data that's relevant to the rollup. Then rollups could have their own peer-to-peer networks to doing backup. Rollups can back up to Filecoin. I'm sure some of them are going to do that, thinking of or doing that already. Then if you don't want to trust that, then kind of the backup guarantee is like what kind of actors are going to continue to reliably store all Ethereum data going forward into the future, right? That's definitely a more limited set of actors than today, right? Because today, it's basically like everyone who runs a default Ethereum node is one of those actors, right? Mm-hmm. In the future, there's I think basically probably three types of actors, right? One is like these peer-to-peer networks collectively, right? So the Portal network, this is one of those really important projects, I think, for people interested in L1 infra to really be following. It's a decentralized peer-to-peer network that's basically it's basically like decentralized Internet Archive, but for the Ethereum blockchain, right? Okay. And the way that it would work is basically, every client only stores a randomly selected small piece. And for any individual piece, there's going to be hundreds of nodes that store it. And then because of erasure coding, you actually have even stronger guarantees on top of that because you can recover. And so that's so that's one thing, right? Through the Portal network, Ethereum participating Ethereum nodes collectively. Then you have obviously block explorers, for block explorers, it's important to remember that for an individual, the cost of storing all of Ethereum is going to be is going to get high, but for block explorers, the cost is trivial, right? Yep. And so we can even do the math, right? So a blob, 128 kilobytes. Currently, we're doing 3 blobs per slot, and then plus average size of a block, which is I think right now 180K, and I'm gonna guess go down a bit now that people are switching to blobs. So let's we'll just be conservative, call it another 256K. So I could say you have about 600 kilobytes averaging per block. Then you have 2.5 million blocks in a year, right? Mm-hmm. 2.5 million blocks multiplied by 0.6 million. That's going to be 1.5 trillion bytes per year. So 1.5 terabytes per year. That's still, it's it's decent, right? It's default laptops are not going to be able to store it, right? But at the same time, if you're a hobbyist, that's totally within range, right?
Yeah, and Ethereum on ARM at home.
Exactly, and then, eventually, the number of blobs is going to increase and increase, and with full dank sharding, you have, the goal is to get to 16 megabytes per slot, and then we're going to talk about, potentially, hundreds of terabytes a year, but still, right? The Internet Archive is going in the exabytes, right? So. From a just dollar perspective, it's not that big a cost, right? Okay. So block explorers, and then the other one is just any large and institutional stakers. I think for a lot of people, it's just a why not sort of thing, right? Yeah. So basically, I think there's the Portal network, and there is a pretty sizable collection of actors for whom it's a pretty small cost, and why not just do it? It's a thing that any of these community groups that are trying to help people to run nodes. I think it makes sense for them to run one of these as well. And so I think it makes sense for lots of organizations around the world to have hundreds of backups of this. I personally am not worried at all about my coins on layer 2s. I think if Ethereum infrastructure starts breaking that badly, there will be like many other pieces of proof of stake that break first.
Makes sense. Thank you. You touched a little bit on full sharding, full ring
Yes.
sharding.
Yeah.
So this upgrade today was obviously a massive catalyst for all rollups and most L2s
Yes.
in the ecosystem. What do you think is the next big hinge point for
Yes.
rollups?
Yeah, so one thing that I think is really important to touch on is like the way in which proto-dank sharding has been designed to be forward compatible with like more scaling going forward into the future. Basically, yeah, the way that it's done, right, is that the blobs are stored in a separate object that's like separate from consensus and execution blocks, right? And so the way that you validate the presence of a blob is pluggable, right? And so even today, it's possible for blobs, for users to start building and using clients that use mechanisms like data availability sampling to check if blobs are there, right?
Okay.
So data availability sampling is like this method for checking if blobs were actually published, where each node like randomly selects a few sections of a blob, and then they check if just those sections are there. Like they basically ask other nodes for just those sections, and if they receive just those sections, then they verify that the blob is there, right? And like the key piece of math that makes this work is basically that like if you, because of how blobs are polynomials, if you have half of a blob, you can recover the entire blob, right? And so like this kind of probabilistic checking is actually good enough. So users themselves, like basically, yeah, we can start building this like data availability sampling based verification completely independently of doing any kind of forks. And so the only consensus change that's required to get us from where we are today to full dank sharding with 16 megabyte sets of blobs is increasing the parameter. That's the only consensus like hard forking change that's required. So that's one thing, right? And so basically there's like work that can happen in the back end, and like we're going to have hybrid networks where some nodes are fully verifying by downloading, other nodes are data availability sampling verifying, and you have both coexisting. And the other way in which it's forward compatible is technologically forward compatible, right? Because the blob verification opcode also returns the field modulus, right? And today the field modulus is like based on the BLS curve, but in the future we might decide to upgrade, like we might decide to switch to 64-bit fields because apparently 64-bit fields are the new cool thing, might even be 51 or 31 bits or whatever. And so like we have a lot of wiggle room to upgrade the technology, and the rollups can be built in such a way that they're forward compatible with that as well, right? So basically, yeah, the technology that's the architecture that's put in place today is designed to be forward compatible with all of these changes going forward, potentially like a decade or longer into the future to like continue increasing scaling and also increasing security further, right? Like I know like especially like Starkware, you love Starks, and like I know a lot of people in this community are like very like worried about like trusted setups, which are a thing that dank sharding introduces, right? But one of the kind of long-term ideas here is like eventually, like I think when quantum computers come, we have to upgrade to Starks, right? And like I think we're very pro upgrading to better technology as soon as it becomes more mature enough. And like the infrastructure is in place for us to be able to do that without disrupting rollups and without disrupting applications. So yeah, this is like these are all things that we have thought of, and like we absolutely believe in like long-term upgrading toward transparent and eventually quantum-resistant proving systems as well.
Thank you. So you mentioned past upgrades. We just had the one, and there's others in the pipeline. When does it stop? Like, what can you talk a little bit maybe about the concept? I know you had a post about this a few years ago about features escape velocity.
Yes.
Is there a point at which Ethereum doesn't need to change anymore, and innovation happens elsewhere, or not really?
I'd say yes. So. I mean, these roadmap images that I've been publishing like every year, right? They they're the result of just like myself observing things that people are working on, talking with a lot of the different developers and researchers, and if you look at the changes, like the amount of changes that happens every year is definitely decreasing, right? And there's there's a lot of things that I think are really stabilizing. So for example, one thing that's stabilizing is like the proof of stake. Like there's a desire to do single slot finality, and there's a desire to make some changes to make sure that it's economically stable and like deal with MEV concerns, liquid staking concerns, economic centralization, and like I think if the choice is to continue evolving or to become centralized, I think it's good to continue evolving. But at the same time, like more and more things are being actually fixed, which is good. From a scaling perspective, there's a roadmap on the data availability side, and then there's the roadmap on the side of rollups themselves and layer twos, and trying to get first stage one, and then get to stage two, and increase security over time. And it's becoming more and more well understood what that is. On the side of making it easier for people to run nodes, so the next big thing is the Verge switching to Verkle trees. And Verkle trees, by the way, have no trusted setup dependency, right? Like they're fully KZG based, or sorry, not KZG based, IPA based for anyone who cares about what that means. But and then in the longer term, I think there's a desire to upgrade to Starks, I guess when quantum computers become an issue. Then account abstraction, like EVM changes, like there's a set of specific things that people want, and like there's a specific set of boxes, and like the boxes are being checked off, right? Like the merge has been checked off, proto-dank sharding is being checked off. I think the Verge is going to get checked off. Account abstraction is this thing that's continuing to get in progress, and I think there's a growing realization around the need to make some in-protocol changes to really make that work for users. So continued progress on all of those things, yeah, I think the rate at which boxes are getting checked to me is definitely much faster than the rate at which new boxes are getting added, and it does feel like it's like the research direction is shifting from like feature addition to maintenance, which I think is very good, and I think is very positive, and I think 3 years from now things are going to go much further in that direction.
Fantastic, thank you a lot. I have maybe one short last question.
Yes.
We know what Ethereum can do for rollup. Blobs were a massive major feature. What can rollups do for Ethereum?
Yeah, I think helping Ethereum scale is obviously super important. Another thing I think that's important is that I think in addition to being a technological layer 2 for Ethereum, I view a lot of layer 2s as also being kind of economic and cultural layer 2s for Ethereum. And what I mean by that is that like Ethereum core has a very particular culture, right? And it's optimized around being very ideologically pure in a lot of ways that I think we really value. It's optimized around preserving the sanctity of the base layer, preserving the neutrality of the base layer, preserving a lot of things that people care about. It's definitely not optimized around appealing to users, for example, right? And I think one of the really valuable things about the Ethereum community is how it's this like very heterogeneous thing where there's lots of different groups that have a lot of different styles and different focuses. And I think layer 2 teams do a great job of reaching out to users around the world, right? And I think you guys do a great job of that. I think a lot of the other teams also do an amazing job of that. I mean, Scroll has been doing that more and more. I mean, Polygon has been great at attracting many kinds of users, with Optimism and Coinbase, obviously, and Arbitrum and all the various use cases on that, right? So, I see it as like different L2s having a lot of these different, not just technological focuses, but these kind of cultural focuses on supporting appealing to different kinds of users and really trying hard to actually make things friendly to users and bring them in, which I think is amazing. Also from an economic perspective, funding things that the Ethereum protocol by itself doesn't fund, and I'm a big fan of the way the Starknet airdrop was conducted, for example, right? I think rewarding solo stakers was great. Rewarding all kinds of different contributors to the Starknet and the Ethereum ecosystems from a code perspective was great. I think a lot of things there were amazing. I mean, obviously none of these airdrops are perfect, but I think it's it's important to remember that there's visible errors, but then there's the invisible error of doing nothing. And if you never make errors of doing the wrong thing, then that means that you're making huge numbers of errors of never doing the right thing, right?
Yep.
And I think big kudos to the Starknet ecosystem of really blazing the trail on that, and just continuing to do the job that you guys have been doing on advancing the technology. Yeah, and I've been observing, Starknet over the last 5 years, really, coming to age, in terms of just having this cultural brand and technological brand, and being its own thing. And to me, that's super amazing, and I'm excited to see where this ecosystem goes in the next 5 years.
Thank you, Vitalik. Thank you for that.
Yeah.